Okay, so I'm in the study plan for your Test 1 online. I want to make a review for you here. So if you click on the study plan and make sure that up here it says Test 1 online, you'll be able to get in here. Now my Quiz Me button is grayed out because I ran through that. But if you just click on the practice button, you can work through some of these. It'll give you plenty of practice with these, and these will be similar to what you're going to find on your test, right? So is this a qualitative or quantitative? The population, so that's quantitative. It's measured by measuring or counting. And the thing I like about the practice questions is that you can check your answer. If I can move this up, so I can check my answer. When you do the Quiz Me button, you won't be able to see whether your answer is right or wrong. Heights of tree, that of course is going to be quantitative because those are numerical measurements. And they're going to give us 7 of these weights of pumpkins at a fair. That is quantitative because these are numerical measurements. And again, we can check our answers with the Quiz Me button. You won't be able to check your answers until after you submit it. Okay, so I'm going to break out of here and move on to the next section. And we ought to be able to use the Quiz Me button for 1.2. Now the Quiz Me button is live, so let's take a look at the Quiz Me. We'll start it. Okay, wait times at a doctor's office, that is quantitative because wait times are numerical measurements. And we move on to the next one. Time in hours, that's another quantitative because we're measuring it by counting. Political party, that's qualitative, right? Because those are attributes or labels. And types of trees in the park, again, that's going to be qualitative because those are attributes or labels. We can't really measure those with numbers. Breeds of dogs, again, qualitative. Those are attributes or labels. So those are the types of questions you can expect to see on the Test 1 online. So I'm going to go back to my study plan here. It keeps bumping me to Test 2, but I want to stay with Test 1 online. Let's try the Quiz Me button for 1.3. Start the test. Determine whether it's true or false. Using a systematic sample guarantees that members of each group within a population will be sampled. So remember, systematic is like every 10th person. So that is, it's definitely false, right? We're just counting every 15th person that comes through somewhere. But stratified is where we break the I didn't want to submit the quiz. We break the population up into groups that have similar characteristics, and we take samples from each and every group. Okay, what is the difference between the census and the sample? So the census is what includes the entire population. Sampling, we try to get a representative portion of the population. We only get a part of it. What's the difference between an observational study and an experiment? So in the experiment, we do indeed apply a treatment. No, we don't apply it to the entire population. Let's see. Part of the population, responses are observed. In the observational study, we just measure characteristics of interest of a part of the population. That would be your observational study. Right? Experiment's going to be a little bit more powerful and conclusive. Double-blind experiment is used to increase the placebo effect. That's not true. The double-blind is hopefully going to decrease the placebo effect, right? Where somebody is blind to what treatment they're getting, the placebo effect might certainly affect it, but we have a group to compare the placebo effect to an actual effect to. The average age of the 55 employees of a company. Determine whether you would take a census or use a sample. If there's only 55 employees of a company, we probably could get a sample because it's small enough and practical to do that. And so we submit the quiz, check our answers, and make sure we got everything right there. So you will be able to check it on the Quiz Me, but you just have to submit everything first. That's kind of why I like working through these. The disadvantage is there's just a lot of them. You're going to see there's many of these, so I'll try to get through as many as I can for your review. And then if you can have this video handy while you're taking your test, that might be helpful to you. Okay. So 2.1, these are questions now where we start to look at putting numbers together. So I may not go through every question in this quiz, although it looks like it's just one of them here. So first part of this here, I want to find the midpoint. If you remember, the way we find the midpoint is we add the two endpoints, 15 plus 25. Those two add up to 40. Okay, so 40 divided by 2 would put us at our midpoint of 20. All right, I'm going to do one more, and then I ought to be able to see what my class width is, and then I should just be able to add from there. So I'm going to take 26 plus 36 and add those together, right? When I add 26 and 36 and add them together, I get 62. Divide that by 2 gives me 31 for that midpoint. I'm just going to check one more time, make sure that I get 41 for this. So when I add, or 42 rather, 37 plus 47, I get 84. 84 divided by 2 is 42. So notice, what are we doing each time? We're adding 11. So the next midpoint ought to be 53. The next should be 64, 75, and then finally 86. Okay. What is the relative frequency? So remember, relative frequency is the decimal amount, right? So I want to take 18 and divide by the total. So the first thing I need to do is figure out what that total is. So since they add up to 365, it's probably days of the year. So what I'm going to put in this box is going to be 18 divided by 365, and then I'm going to do that the rest of the way. I'm going to do 18 divided by 365. So I'm going to take the actual frequency, divide by the total, and get relative frequency. So that's 0.049, which I think the 2 decimal places would be 0.05. That's probably what they want. Yeah, round to the nearest 100. So I'm going to do that with each of these. Take the number that is the frequency, 18, 45, 66, and so on, and divide them all by 365. So you notice what I did here. I took all these numbers here, all your frequencies, 18, 45, 66. I'm not dealing with the midpoints anymore, and I divided them by 365. And I get those relative frequencies. So cumulative frequencies, what am I doing here? Well, after my first entry, I only have a total of 18. But in the next one, I'm going to have 18 plus 45. And that's 63. And now to get this next number, I'm going to take that 63 and add the 66 to it. I just keep on adding. So now I'm up at 129. Then I'm going to take 129 and add 67 to it. Puts me at 196, and so on. I'm just going to keep adding. So by the time I get to the end here, I should have 365. I should be at my total. I add 78, and I'm at 274. Let's add 66 to that, and we're at 340. And then we are going to go ahead and add another 25, and that should be an indicator that we did this correctly, because we get the total of 365, which is what we got from the start. And that's our whole quiz for that one. Oh, looks like we missed some kind of part of it. I probably typed something in wrong there. Yeah, the 0.18, I probably rounded wrong. Let's see, what did they want there? Oh, I put 0.15. So my guess is I did 53 divided by 365 by accident instead of 67 divided by 365. So we're okay on that one. All right, so let's try still test 1 online. Let's look at our interpretations of frequency polygons. Okay. Do some quiz me here. Okay, so what are the boundaries of the class with the greatest frequency? So the class with the greatest frequency, if I zoom in, I guess that's as far as I can get in here, is certainly this one that has 28 down at the bottom of it. Okay, so that the boundaries of that class. So I want to notice what I have here. I have midpoints, right? If you look above 25, you can see 25 is a midpoint, 28 is a midpoint, 31 is a midpoint. So that tells me that my class width has to be 3. So the class boundaries that make this most sense here for that class, where 28 would be the midpoint, would have to be 26.5 to 29.5. Okay. The boundaries for the class with the lowest frequency so that's the one where 10 is the midpoint, and again our class width is 3, so we need 10 to be the midpoint and live right at the center of that. That would be that second one. Oops, don't submit yet. We'll move on. Let's see how many of these we have. Okay, so the OGIB, or the cumulative frequency histogram. What is a cumulative percentage or cumulative frequency for a weight of 27.5 pounds? So I look at 27.5. I'm going to run my finger up here, and it looks like it lives just up above 40. So I suppose unless I can get in any closer, I'm going to have to estimate that. Cumulative frequency for a weight of 27.5 pounds. So I roll right up above 27.5, and it's just above 40. I'm going to say that that's 41. What is the weight for which the cumulative frequency is 45? So I'm going to come over here to 45 and run my pencil along until I hit that dot on the corner. Drop straight down, and it looks like it's at 30.5. So we're just reading and interpreting the graph. And how many beagles weigh between 22.5 and 29.5? So at 22.5 I'm at 10, and then at 29.5 it looks like I'm all the way up at 44. So 44 minus 10 would be 34. How many beagles weigh more than 30.5 pounds? So there's 45 that are at 30.5, so more than that would be just the next 5. Okay. And now we're looking at the histogram. So it's not really clear whether they want the boundaries or the class limits, but I can see that that class, the midpoint is 40.5. Also, since we're increasing by 2 every time, I know my class width is 40.5. So if we were looking at the class limits, we would just go one to the left and one to the right of that, or class the boundaries rather, and you would be that would go from 39.5 to 41.5, right? Just add 1 in each direction of that, or add and subtract, to 41.5. Okay, so if they wanted the class boundaries, we could use those as our boundaries. The class with the least relative frequency, we can see the midpoint for that is 48.5. So that one would go from 47.5 to 49.5. And of course, if they wanted the limits, then we could just simply round these up. That class would go, like this one would go from 40 to 41, right? This would be, depending on what they want here, this would be 40 to 41. It's not clear to me which one they wanted, so hopefully they'll take either one. Their greatest relative frequency is about 0.25. Okay, and the least relative frequency is about 0.01, I would guess. Okay, what pattern does the histogram show? Now I didn't add any percentages up, but if we go from 39.5, it's like right in the middle, to 41.5, that says that that's about 25%. That sounds about right to me, and it looks like that's where we estimated that bar to go to anyway. Okay, so just going to be repeats of these the rest of the way. I'll go ahead and finish up this section. Okay, so I didn't answer the last 2, but it looks like we were okay on the 3 that we answered, so the midpoints are just fine to use there, the class boundaries rather than limits. I think that's an easier way to get it when you know the width. Just subtract 1, add 1, and you'll move right through that. Okay. Still jumping me to test 2, not so fast. Test 1, quiz me's are done. Interpreting some graphs here. Try some of these. Okay, so we have a stem and leaf display. We want to see which one this matches up with. So I can see my lowest number has to be 25. The next one is 33. So A and D look okay so far. So let's see. Do we have 242s in both lists? We do not. I have 242s here, and I can see that that's correct by the stem and leaf plot. So the maximum entry in this stem and leaf is 85. The minimum entry is 25. That's all I want to be able to do with that. Okay. Now we have a dot plot. Okay, which plot represents the data? Okay, so here this might, if the data are not sorted for us, we might see if we can organize them ourselves. So there's 30 numbers there. Since I can't rely on StatCrunch to be available on the test, you can open StatCrunch in a separate window if you want to use it. I'm going to rely on my calculator. So I'm going to take all 30 of those numbers. I'm going to clear this list that I have here. I'm going to put all 30 of those numbers in a list on my calculator. Okay, so I double checked. I have the whole list there. Now, I think the easiest way to do this would be to hit second quit in mode. And I'm going to go to second stat and organize this list. So when I hit second stat, I have my list menu. And under options, I can sort this list ascending. So I'm going to hit sort A. It comes up on my screen. I'm going to hit second and the number 1 for L1. And it doesn't look like anything miraculous has happened. But now when I go to stat and edit, my list is edited. And I can see I have a 4, 2 5s, a 6, a bunch of 7s. Okay? So let's go back to the problem and see if we can see that. A 4, 2 5s, 1 6, a bunch of 7s. 4, 2 5s, a 6, and a bunch of 7s. Looks like this one. B seems to match as well. So it's either A or B. Kind of hard for me to tell, but let me go back to my list. 4 2 5s, 6. How many 7? 1, 2, 3, 4, 5 7s. How many 8s? 1, 2, 3, 4, 8s. 5 7s. Nope, 5 7s and 5 8s. Let's see if we get a discrepancy with either of these. They both look. Okay, yeah. So C is not right. We need more 8s to make that one right. So what does dot plot suggest about the distribution of lifespan of houseflies? So we'll look at these. The lifespans range from 4 to 14 days, with most lifespans less than 5 days. That's not true. Most lifespans range 10 to 14. That sounds a little bit more accurate. The lifespans range from 4 to 14, with most greater than 13. That doesn't seem true. B seems to be the most true. Let's see what D says. Lifespans 4 to 14, with most in the range of 9 to 13. 10 to 14 or 9 to 13. 10 to 14 sounds a little bit more reasonable to me than the 9 to 13, because I don't see anything at 9. If I look at my list here, yep. Okay, so here, this is a little bit interesting. We're going to split the stem, so let me show you what that means. So next to this 3, I'm going to put any number that comes from 30 to 34. So the 36s won't go there. I'm going to ignore them for a second. Neither will that 35. I'm going to continue scrolling through that list. The 34 will go there, and it looks like I have 1, 2, 3 34. So I'm going to put a 4, 4, 4. Now I go to my 35s, and I see I have 1. I only see 1 35. Then I see 2 36s right away. So I'm going to say 5, 6, 6. I'm going to look to see if I see any other 36s. I do not. I then see a 37. I'm looking to see if I see any other 37s. I do not, but I do indeed see a 38. Okay, so that's how I'm going to do that when I get into the 40s here. Any number that's between 40 and 44 will live in that list. So I don't see any 40s, but I do see a 41 in that second row. And then I see right next to him a 42. Then I see no 43s anywhere. But then I do see a couple of 44s, one in the first row, another one in the second, so I put them there. And that's how you're going to set up this particular stem and leaf. I'm not going to go through to the finish on it. So again, we were okay on the ones that we submitted. We didn't submit the second 2 just to save time for me to make a video to review the entire test. But you'll be able to complete the rest of those on your own if you choose to. Okay, let's get back to test 1. More graphs. Start. So this is pretty simple here. I just want to find the percentages, the options that are true here. It looks like the 2 cautious drivers, right? That's 2%. That does look like that's the least percentage of all of them. Okay. What irks drivers the most? Looks like my highest percentage is at 23%, and that is indeed the tailgating. And to say most drivers are irked by the same thing is not true, because we don't have anything over 50%. So you're just looking for what conclusions could be accurately drawn from that picture, right? So here we have the average owning and operating costs for 4 types of vehicles in a country. Small sedans, $68.11. Medium sedans, $81.30. SUVs, $10,387. And minivans, $9,209. So the minivans should be the highest. I want to find the one that has, SUVs ought to be the highest. So as soon as I find one, I look at A and D right away. They have SUVs the highest. The next highest ought to be the minivans. So I see SUV and then minivan. So this has to be the correct Pareto chart, right? The blank type vehicles have the greatest average cost to own. That would be the SUVs, as we said. And the have the lowest would be the small sedans. Okay, and I'll just post those 2. And again, just to save time, I'm going to submit after a couple too. You'll see when you take the quizzes they ask the same types of questions. So as long as I do a couple in the video for you, I think it'll be sufficient for review and study for you. So I'll get back to study plan. Okay, and now we can move into measures of central tendency like mean and median. Okay. So determine whether the statement is true or false. Some quantitative sets do not have medians. That's going to be false. Any set of quantitative data, we can calculate a median, right? We can find a middle number. That's no problem for any quantitative set. The mean is the measure of central tendency most likely affected by an outlier. That is definitely true, right? If we have one really big number, we add that to the total sum, it's going to affect the mean for sure. When the data class has the same frequency, the distribution is symmetric. That's not true. That's called a uniform distribution. Okay, so if reading this a little bit more carefully, it's not. If everything has the same frequency, that's like rolling a die 1 6 1 6 1 6 1 6. It's not skewed left, right, or bimodal, but it would be symmetric. It is even on both sides. But generally, we would call that a uniform distribution rather than just saying it. Of course, it's going to be symmetric, but all the bars are the same height. It's a uniform distribution. A data set can have the same mean, median, mode. Sure, that's possible. Could make that happen. Okay, so that's our measures of central tendency questions there. Pretty easy. Okay, so the mean is not representative of a typical number in the data set. Okay, so we want to construct a particular data set here. I didn't actually have to do this on my own, but we just find the textbook definition of the mean, and then clearly I can see if I take 3 and 3 and 14 and 14 and divide by 4, I'm not going to get a number that's actually in that set. Every other measurement there, the mean would actually be a number that's in the set. Definition of the median, that's your middle. So here we have median and mode are the two definitions. So the median lives in the middle, the mode occurs most often, and then the last one where we have 1 1 and 6 6 on the ends, and then 5 living in the middle occurring most often, that's where your median and mode would be the same. Okay, so here we want to describe the shapes of some distributions, whether they're skewed left or skewed right. Consider a frequency distribution of scores on a 50-point test where a few students scored much lower than the majority. Right? So if a few students scored much lower than the majority, that would be this one here, which is D. Right? And that we call that a skewed to the left distribution. Right? If somebody scored, a few people scored really low, a couple of low numbers, that's skewed left. This one here is going to be skewed to the right. The shape of the distribution is skewed right because the bars have a tail to the right. That is the correct way of describing that shape. Okay. Match the frequency distribution of 190 rolls of a dodecahedron with one of the histograms below. So if it's a 12-sided die, it ought to land on the same number with about the same frequency. So that would, to me, would be this first one here. So which histogram would most likely be that? I'm going to pick B. I don't know why they gave me two different groups of 4 there. It's bizarre. Okay. Determine whether approximate shape of the distribution is symmetric, uniform, skewed left, skewed right. This would definitely be a uniform shape. Okay, they're all the same height. That's what I was saying earlier. This is your mound-shaped symmetric, right? The shape of this distribution is symmetric but not uniform because it's not all the same heights. So I had a pretty good roll on that one. A lot of conceptual questions there, so let's get back to the study plan. Finding measures of central tendency. So hopefully we can lean on our calculator for this, and not so much StatCrunch. So here, since we're dealing with the nominal level of measurement, we can't really calculate a mean, right? Same thing with the median. Okay. Does it represent? Again, we wouldn't have a median for categorical data. Find the mode. Okay, so here, if you want to use, again, you have StatCrunch, but I'm going to just use my calculator. Okay. I'm going to take those numbers, enter them in a list in my calculator. If you recall, we want to go to Stat and Edit. and we got to clear our list. So I'm going to hit press clear, drop down, and it's gone. Now we're going to put those numbers. Okay, so when I enter that, I'm going to go to stat, calculate my one variable statistics for that list. Okay, and there's my mean, 10.585, or let's see how many decimal places they want, 10.6. Okay, does the mean represent the center of the data? It seems like a reasonable measurement of the center of the data. What is the median score? So again, I can jump back to my calculator for that and arrow down. Median is 10.6. And it sure represents the center. What's the mode? Do we have a mode here? 11, 9.9. Looks like 9.9 is our mode. And we had one of these in the homework problems. It's not going to be representative because it's the smallest number. So we don't want to consider that to represent the center of the data. Okay. Okay, find the range, variance, and standard deviation. So again, we'll lean on our one variable stats on our calculator for these. They give us a list of numbers. We'll enter them in the calculator. So here we're going to have to click on the graph. The range of the data set looks like it goes from 34 to 24. So if we subtract 34 minus 24, that range would be 10. Okay, range is max minus min. So here it might be worth our while to put these in our calculator list again. So again, stat, edit, and let's clear this list. Okay, and we'll enter. So once I get that list to my calculator, I can let my calculator do the work for me. Oops. So on stat, calculate one variable stats again. And remember, if your list, if it doesn't look like mine, and it just looks like this, make sure it just says L1 there. The first thing I think they asked us for was the range, so the calculator doesn't give this to that right away, but we can take our max 23 minus our min 12 and come up with a range of 11 for that. Okay. The mean is the very first number that they reported to us. Whoops. Bring that back up again. 17.6. The variance, not sure that they give that to us, but our standard deviation is 3.3823, so our variance is 3.3823 squared. Let me just see that one more time, make sure I got the right number. 3.3823. .3823. Okay, 3.3823, and we'll go ahead and square that. That'll be our variance, 11.44. And then the standard deviation. If they don't ask us for sample standard deviation, usually that's generally what we're going to use is sample standard deviation. It should be 3.6, or since we used 3.38, we'll use that for our standard deviation. So reading this a little bit more carefully, it says this is a random sample. So I'm going to use my sample variance and sample standard deviation instead. So for variance, let's take the 3.565 and let's square that. So we'll use 12.71 as our sample variance, since it does say it's a sample. I'm going to trust that. And then my standard deviation to the nearest tenth would just be 3.6. Okay, again, I'm going to skip ahead, but we were A-OK on question 1 and question 2 there. So we can head back to our study plan. The rest are just going to be repeats of the same kind of question. Okay, and then This is another one of those constructed data sets. So they're going to ask us conceptual questions about measures of variability. Which data set has which deviation? So both sets have a mean of 185. One has a standard deviation of 16, and one has a standard deviation of 24. So let's look at the two of these. So the one that has the larger standard deviation has more variability. That's going to be letter A. Can you see in B how it's more symmetric and mound-shaped and has a little bit less variability? So A is going to have the larger standard deviation. So I want to say that A has that larger standard deviation. Okay. Which one has the greatest, which data set has the greatest sample standard deviation? So I want the one that has the most variability, the largest amount of spread. Just looking at the ranges, I can see they all have the same ranges, right? But again, I have out here in this third one here, I have more values in the tail. See how there's 2 9s and 2 5s, but over here there's only 1 5 and 1 9. That means there's more numbers closer to the middle. So the greatest sample standard deviation would have to be data set 3. The least sample standard deviation is where everything's huddled close together. That's going to be Roman numeral 1. And how are the data sets the same? How do they differ? Well, they all have the same centers. They all have the same mean, median, mode, but they have different standard deviations, right? They all have that mode at 7, mean at 7, median at 7, but their variability is different. Okay, so again, chapter 2 is by far our, most topics covered. So again, I'm going to take this list of numbers, and I'll be able to get my 5 number statistics. But what I'm going to do for the outliers is use my box plot. Okay, we did this in the homework assignment as well. Okay, so the box plot is going to be the most expedient way to get this one done. I'm going to hit second y equals. My plot is turned on. I want to make sure that this box plot here, the modified box plot that'll flag outliers, is highlighted, and then just L1. So my shortcut to get the graph I want is zoom 9. And there we go. We can see that we do indeed have an outlier. I'm going to hit my trace button to get those quartiles. Okay. So my first quartile, Q1, is 35.5. Q2, which is the median, we just arrow over to him. And he is at 40. The third quartile is 46. And then what's the IQR? That's the difference between these two. 46, I can probably see it better on the screen. 46 minus 35.5. So if my arithmetic is right, that's 10.5. Right? 46 minus 35.5 would be 10.5. Are there any outliers? Yes, there exists an outlier. Let's go get them in our trace feature here. 15 is an outlier. And the box plot flags it for us. Okay, so for review purposes, no need to do the same question, exact question twice. We got question 1 100% right there. And I think we might be able to move into chapter 9 now, correlation and regression. That should be pretty simple, conceptual. Okay. 2 variables have a positive linear correlation. Does the dependent variable increase or decrease as the independent increases? Well, if they have a positive correlation, then they both increase together. One does one thing, the other does, right? Which value of R indicates a stronger correlation? 0.778 or negative 0.917? The negative 0.917 is a stronger correlation because with the value of R, it's a negative association, but that just, it doesn't measure strength. It's the absolute value that's closer to 1 that measures how strong the relationship is. The sign just measures the direction. Explain how to determine whether a sample correlation coefficient indicates that the population correlation coefficient is significant. So this is not something we're going to do, but just even when we do statistical inference, we don't do it for correlation, but that's how we would do that. We compare the sample R with a critical value to see, and we use what's called a t-test. Range of values of correlation coefficient, they go from -1 to 1, inclusive. Okay, and then give examples of 2 variables that have a perfect positive linear correlation and 2 variables that have perfect negative linear correlation. Okay, so perfect positive correlation definitely would be price per gallon and total cost, right? As one goes up, the other goes up exactly the same. It's just going to be a multiplier by the number of gallons you get. And perfect negative would be the distance from a door, right? Distance from a door and the height of a wheelchair ramp. As one of those goes up, the other one inevitably would have to go down. Okay, and all of those were a perfect score. And then the last section on your first test. Oh, still got a couple more quiz-me's. Value of home and lifespan are two variables that have been shown to have a positive correlation, but no cause effect. Describe one reason why. It's likely that we have a third variable like income, right? If somebody happens to be wealthier, they might have a more expensive home, but they also might be able to afford better health care, and also, maybe exercise programs, or they eat a more nutritious diet, and all those other factors. The home doesn't directly affect how long you're going to live. Doesn't seem like that would be reasonable. So I don't think I read the first one very carefully. I didn't see they're bringing the third variable of exercise into play and amenities. I think that's connecting an awful lot of dots, but so their correct answer there was the first one, not the greater wealth. Okay, is it appropriate to use a regression line to predict y values for x values that are not in the range of x values? That's not. We call that extrapolation. So it should be not appropriate because of D. So this would be like, using shoe size to predict reading level. That would work at elementary school, but if we move past that, probably not a great idea. What type of correlation, if anything, do you think that they have? Really have to read these carefully. This is strong positive linear correlation. B almost reads exactly the same, but it says as one increases, the other decreases, and we would not have that with a positive correlation. Okay. What is the residual? That's your observed value and predicted value. We subtract the two. So again, make sure you read this one carefully. The residual, it's always the actual value or the observed value minus the predicted. So read that carefully. It's positive when it's above the line. It's negative when it's below the line. So read that carefully. These are all worded very, very close to the same. So hopefully I have the right one there. And again, we have a scatter plot, right? So an analyst used the regression line for the data to the right to predict the annual salary for a registered nurse with 28 years of experience. Is this a valid prediction? It's not going to be, right? Because x equals 28 is outside the range. The furthest it goes is up to 24. So 28 doesn't look like it would be a valid number to use to make a prediction with. Okay. In order to predict y values using the equation of regression line, we must be true about the correlation coefficient of the variables. So again, not something we focus a whole lot on in this course, but we would want that to be a significant correlation. Looks like we got all of those correct, especially the really wordy one. I was concerned I didn't read everything in there very carefully. Okay, and then one more. Oh, we didn't do z-scores. Let's jump back to our z-scores. Make sure we look at those. I don't want to skip that. Definitely have to have a z-score question on the test. Okay, so the midpoints A, B, and C are marked on the histogram, right? So A midpoint is at 48. Which scores, if any, would be considered unusual? So this doesn't even require that we calculate the z-scores. I can see that A is below the mean, so he has to be a negative z-score. 0 is right, or 63, or B is right around the mean, so that's a z-score of 0 at B, and C is above the mean, so it'd be positive. Unusual z-scores are less than 2 or more than 2 standard deviations above or below the mean. Okay, so now we'll go ahead and calculate some z-scores. So 1 year the best actor was 42 years old, so let's get his z-score. That would be 42 minus the average 43, and then we would have to divide that by 9.2 to determine if that's unusual. Then for that best supporting actor, who was 78, that certainly seems like that's unusually large for someone who's usually 49, and then we would go ahead and divide that by 13. So what I get when I calculate those respectively, here I get negative 0.11, and over here we do get 2.23. So this is negative 0.11 and 2.23. The best actor was less than 1 standard deviation below. That's true, which is not unusual. The best supporting actor was more than 2 standard deviations above the mean, which is unusual. So I think that's good enough practice with the basics of the z-score there. And now we can jump back to finishing up our regression question on the quiz me. Okay. So we want the equation of the least squares regression line here. So we're going to need to use our calculator for this. So this will take a little bit of time to put into my calculator, but length is going to be x and girth is going to be y. So I'm going to need 2 lists for this. So we go to Stat, Edit, and I'm going to clear this first list. Alright, I'm going to enter those lengths in L1 and the girths. So here's to hoping I didn't make an error entering one of those numbers there. That would be really disappointing. So I go to Stat, Calculate, and what I want is my linear regression, but we'll generally use number 4 for this class, ax plus b. That's fine. So we want L1 and L2. Now if you don't get a screen that looks like this, I'll come right back to you in a second. Okay. So I also didn't get my r and r squared, so I have to run something on here. But if you got a screen that looks like this, second enter, linear regression, we want to put in L1, comma L2, and then we'll get that. Now, I should have shown this in our first or second or third class, but what I want to do here is go into my catalog. So that's second and the number 0. So hopefully we've all done this, but I'm going to do it again here in case you haven't seen this. If you haven't done it with your calculator, or you got your calculator after I showed you this. But I want to go all the way down until I find the command that says diagnostic on. Don't want to skip past it too fast. It's got to be down here soon. Diagnostic on. So when I press that, press enter, it doesn't look like anything great happened, but if I hit second enter a couple of times and bring back up that regression command, magically now I have r and r squared, which is going to be real helpful to me. Okay, so I need the least squares equation line, so that's my slope, 0.69. Let's see how many decimal places they want for that. 2, perfect. So that'll be 0.69. Fits nicely. And then what was my y-intercept? 10.8. So again, if I entered a number wrong in my list, that's going to be wrong. But so we want to see which one of these scatter plots matches that. So let's go back to our calculator and just do a couple of things here. I want to hit second y equals, and I want to turn a scatter plot on, but this time I want this very first one here. I want the scatter plot. So I'm going to arrow down and make sure the scatter plot is on. And then I'm going to hit zoom 9. Okay? So there's my scatter plot, but they also have the regression line drawn in. So remember what the equation of the regression line was. So what I'm going to do to get that regression line is I press this y equals button. And y has to equal 0.69. And watch what button I press here. It's the xt theta button. I need to press that, not the letter x. Right next to this green alpha here, press that x button. 0.69x plus, well, what was it, 10.5? 10.8. Whoops. And now when I graph, I have my least squares regression line equation there. Let's see which one of these that seems to fit. I think it's this one. I picked the wrong ones before. Let's see. Yeah. Second one doesn't look right again. Okay. So predict the girth length for 140 centimeters if it is meaningful. So it looks like 140 lives in that range, so we can do that. So our predicted value for 140 would just simply be to take that equation, 140 times the slope 0.69 plus 10.8. That'll be our prediction. Just plug into the equation. So I get 107.4. Okay. Predicted girth for 172. If it's meaningful, let's just double check our original data set. Do we have a number as high as 172 in that original data set? In my X list, I see 168. I don't think so, so I'm going to go ahead and say that that one's not meaningful. Yep. It's outside the range, not because it's not an original value, but it's outside the range. Predict the girth for a length of 164 if it is meaningful. I think we can certainly do 164. That's going to be in there. And 158. Yeah, 164 and 158, these last two, we can do both of those. And so 164, 158. So I'm just going to go back and change this to a 164. And then I'm going to go back and change it to a 158. So I get 123.96. Let's see how many decimal places they want. 2. And 119.82. So let's see if that is enough. You can see those take a really long time to do, but we did one of them, and that should be a sufficient review for your test 1.